Okay, so today we'll be working on lesson 6.8, which is basically exponential regression and inverse. So I'm going to start on exponential regression. You'll see that most of the information that you get from me today is something that you have done before. So it's just basically think of it as a review. So we'll be doing number 2 and 4 from the front page. So in number 2 and 4, they're asking me to enter the following data into stat on my calculator. And remember to turn on the graph, so in stat plot, so you can see the scatter plot and determine what kind of function the data represents. So let's review how we can enter that. So you go to stat and then enter. You enter the values in L1, which is -1, 0, 1, 2, 3. As I'm entering the values, well, I don't know what type of function this is, so usually graphing it helps me figure out what type of function it is. Because when you go to calculate, you have to determine whether it's a quadratic or what have you. So now, after I enter the values, you need to graph it. But if you hit graph, you will see nothing. It's because you entered it in the stat. So you need to go to the stat plot and turn it on. So you go to second, y equals. On plot 1, as you can see, it's off, so you press enter on 1, and you make sure that you turn it on. As you can see, the type is going to be the dotted part. So now when you graph it, let me make sure that I pressed on. Now when you graph it, you're going to be seeing the scatter plot. Now what does this seem to you? It looks like an exponential function. So number 2 is an exponential function. Now if we move on to number 4 and you enter the values as we just did. So now -1, 0, 1, 2, 3, the same thing. We need just to change the L2. So let's do that. Now remember the stat plot is already on. So if I just hit graph, it's going to graph the new shape for me, and as you can see, it looks like line. So this is a linear one. Now this is how you can decide what type of function it is. So when you actually go to stat and then to calc, you can decide which one to use, whether linear or quadratic or cubic or exponential and so on. So this is number 2 and 4 from the front page. Now the rest of those is basically for you to enter the values, like use exponential regression to find a function. So you would enter the values in L1 and L2, and then you go to stat, and then calc, and then you go all the way down to exponential regression. Somewhere over here, you press enter a couple of times until you get the equation. Okay, so 5 and 6 are things that we have done before. Number 7, it's the same concept, and 8. Now what I want to do is actually I want to do the back part with you because there are more in detail questions. It's similar to the one before. So I'm going to be doing number 9 and 10 on the back page. The rest is going to be just similar to it. So let's start with number 9. She wants to sell seashells, and the price of each shell, okay, depends on its length. Okay, so we have length is going to be my x and price is going to be my y, since the price depends on length. X is the independent and y is going to be the dependent, which is the y. So exponential model means they want an equation. So you go to stat, edit, and then you enter the values. See, this is why I didn't do the back ones, because this one has like everything in it. So it's a good review. So I'm entering the values. Go ahead, please do that with me. Okay, and above you have 2, 3.5, 5, and 18, and 40. Okay, now I go to stat and then calc. You go all the way down to exponential regression because they said exponential model, and then you keep on pressing enter until you get the equation. So it's a times b to the power x. So I'm going to do that. Let me make this bigger so I would actually be able to write down. So it's going to be 0. Remember, always round to the third number or decimal place. this is the A, times B, which is 1.159 to the power x. Now, I know they're not asking you for that, but I would like to review something with you. Now, this is your function. Now, as you can see, this is what you look at, which is the b to decide whether it's growth and decay. And since it's greater than 1, then this would be a growth problem. And they already said that it's growing, as you can see. As you go from here to here, it is growing, but I just wanted to review this concept with you. Okay, now let's move on to part B. What is the length of a shell selling for $9? So they're asking, what should x be if y is 9? Now there is a couple of ways where you can do that. The first way is that you can go to y1, enter the equation, and y2 enter 9, and then you can go to second table. If you see it, great. If you can't, you can go to second graph, or you can graph it and find the intersection. So let's do that. Now y1, you can enter the equation that you just put over here, so you can type it in, or there is a way that you can ask your calculator to type in everything for you. So you go to vars number 5, which is statistics, go all the way to EQ, then press enter on C, regression, press enter, regression equation, and then the calculator copies the equation, all of it, for you on y1. You can decide to do that, or you can type in whatever you have over here, so it's up to you. And in y2 you put you put 9. I'm going to make this bold. Now you can graph it. That's my graph. Okay. Now, as you can see, I can see the scatter plot because I entered some values over there, so you can turn it off by going to second, y equals, press over here and then go to off and press enter. This way, whenever you see the graph is going to be without the scatter plot. But let's look at, this is going to be my y1, and the line is going to be my y2. As you can see, I cannot basically see the intersection. So you can fix your window. I can make my y maximum to be higher a little bit, so maybe you can put it to 15 just to push down the line, and then x maximum I'm going to put it to be 20, so I can actually see the intersection. So that's my y1, that's my y2, and there you go, here's my intersection. So to get that, you do second trace number 5. Now, since you can see two numbers over here, the x and y, I press enter 3 times, and it gives me the intersection, which is x is equal to 15. It means when the length of the shell is 15 centimeter, this is when the price is $9. So x is going to be equal to 15 point, I'm always going to take like to the 3 decimal places, 156 centimeters. So that would be my answer. Now, if you move on to part C, so she found a 40 centimeter conch shell. So x is going to be 40, and they're asking how much will this cost. So they want the y. Now, what you can do, there's a couple of ways you can think of it. So you can either go to second table, or maybe, yeah, you go to the table, you go all the way down to 40. Now, what if they gave you a very, very huge number? So 40, as you can see, is going to be 349. Okay? So this is how you can do it. Or there's another way where you can actually go, remember, you go to second, table set, and let me go get that. So I was saying that, let me go back to the graph. Okay, so if they gave you x to be equal 40, there's a couple of ways how you can do that. You can go to second, table set, you can go down to independent, and you can move it to ask. It means you're telling your calculator, like, I want to ask you for a certain value, and then you put the 40, you press enter, and it gives you the answer. This is one way. You can go to second table, but sometimes, okay, let me push it back to independent, to auto. Okay, this is one way. Or you can go to second table, but sometimes if they want a decimal, or maybe the number is really high, you can't reach all the way up. So you can use this way, or you can go to second trace, and then for number 1 press enter, and then you can actually press for a certain value. However, if your window is not big enough on the x maximum to cover x equals 40, then it will not give you an answer. It will say invalid. So you have to make sure, let me clear that. So you have to make sure that the x maximum has to be higher than the value, which is 40, so you put 50. And now you can press second trace value, which is number 1. Okay, come on. Okay, so then you can press second trace number 1 and then put 40 there, and it will give you a value. Okay, so there are 3 different methods. You can choose whatever you want. My personal favorite is to go to second table set, go to independent, and change it to ask, because it works for everything, especially if the x is very big or if it's a decimal point. Okay, so you can choose whatever method you want. So I think the value was like 349, yeah, something like that. So remember to round to the 3rd decimal point. So that's number 9. Now let's move on to number 10. Now would be a good time for you to pause the video and try on your own. Okay, I hope you tried. Now number 10 is basically, a lot of students find it hard because they don't know how to think of it. Now let's read the question. They said the number of bacteria in a colony is growing exponentially. So this is an exponential function, keep that in mind. The time in minutes, this has to be in hours, so please change it. You have 2 p.m. and then 4 p.m. The bacteria for 2 p.m. is 100, for 4 p.m. is 4,000. They said find an exponential function to model the population y of bacteria x hours. This is why I know that this has to be hours. After 2 p.m. So basically think of 2 p.m. as your 0. It's as your reference point. And then at 4 p.m. it's going to be 2 hours from 2 p.m. So that's going to be 2. So when you actually enter it in your calculator, you go to edit. Now over here you can put 0 and then you press 2 for 4 p.m. and then delete the rest. And over here for 0, it means at 2 p.m. This is your reference point, so that's your 0, because they said after 2 p.m. That's your starting point. So at 0 we have 100, enter, and then we have 4,000 at 4 p.m. So also let's delete the rest. Okay, so remember, when they say after 2 p.m. this is your reference point, set it 0, and then after that you count by 1. 4 p.m. is 2 hours from 2 p.m. Okay, now you go to stat and then calc. You go all the way down to exponential because they said it increases exponentially. So keep pressing enter until you get the equation. And the equation is 100 times 6.325 to the power x. So that's your function, which is y equals. Okay? Now, it does make sense because the starting point, which is A, is 100. Makes sense. Use the model to determine how many bacteria exist at 7 p.m. that day. So ask yourself, 7 p.m. is how many hours from 2 p.m.? It's 5 hours. So then they're telling you that X is 5 hours, and they want to know how many bacteria there will be. Okay? So remember, you have to go to Y. So there are a couple of ways you can do it. You can just plug in 5 in here. So you can do 100 times 6.325 to the power 5, and you get your answer, which is a lot of bacteria, as you can see. Another way to do it is that you can go to second table set, all the 3 methods I showed you before, but before that you have to have your equation over here. So I'm going to review, that's a good review. So vars, and then 5 for statistics. You'll go all the way down to EQ, which is equation, regression equation. There you go. Now when you go to second table set and you move it to ask, it's already there. So second graph, and I'm going to type in here for 5, press enter. So it's going to give me 1.01 E6, which means 1.01. E6 means times 10 to the power 6. It means you have to move the decimal places 6 spaces to the right. So this is one way of doing it, and the other methods as I showed you. Now I hope this video was helpful and a good reminder, and this is the regression. Have a nice day.